Hi guys, this video is just a quick review of the classwork that you had today. This is the 3rd of September 2024. So if you're watching this is for the class who's in fall 2024. And so for this question, I wanted to review the entire question as you are practicing and preparing that we can understand this. So there are two parts to the question I'm asking, although the second part has multiple parts. So the first thing is I asked which one is the strongest acid. So let's go through our ARIO again. So first of all, when I look at the strongest acid, I am comparing it to its conjugate base. So if I compare the hydrogen here, and so a common question people ask, well, aren't there other hydrogens? Yes, but if we compare those, we are still encountering the same issue. So a carbon versus an oxygen in terms of wanting to give up its hydrogens, carbon never really wants to ever do that. So that's why I kind of ignore these hydrogens. Now, there are times that we want to look at the hydrogens, and that's generally when I don't have any other factors that I'm looking at. So oxygen is negative here, and I'm just going to add our lone pairs so that we can follow along. And you really want to practice with lone pairs. I know some of you are still a little bit shaky with the lone pairs. Don't hesitate to add them on if you're not comfortable with them, and practice with them. So when I compare my conjugate base, I see I'm comparing the negative charge on oxygen versus sulfur, two different atoms. And when I'm talking about going down the periodic table, I'm comparing oxygen versus sulfur. Oxygen is smaller than sulfur. I'm comparing size. The larger my element is, I can kind of smear that electron density more, making me more comfortable. And so that would mean that this is the most stable conjugate base, which really translates to this being my stronger acid. So that was one thing. And most of you got that part right, which is fantastic. But as I was looking at your muddiest points from your video 4, there are still people who are not comfortable with ARIO, so I definitely wanted to review at least that part of the question. If you do still have issues with ARIO, I would strongly recommend coming to see me and tackling those, because it might be some minor things that you're messing up there. Here's the next part of the question. Now that we know what's our strongest acid, all I did was turn this upside down. I'm going to put my lone pairs back on here. It's said to use hydroxide ion. So hydroxide from Gen Chem was OH minus. So you just needed to draw OH minus. And it's said to use this as your base. And so remember, in class today, we talked about Lewis bases are sharing electrons. And so another muddiest point that I know, and I never said it directly in class, but as practicing, I was kind of hinting at this. In Gen Chem, you learned that Bronsted-Lowry saying that the hydrogens are giving up their the acids are giving up hydrogens. It's not really technically what's going on in your flask. Yes, they're giving it up, but they're not giving them up. Something is taking them. So technically the base is the thing that takes. And it takes with the lone pairs or pi bonds. It's taking. So hydrogens don't just want to, like, for example, this molecule is neutral. It doesn't want to just give up its hydrogen. It doesn't float around and just give up a hydrogen. Something is taking it away. So it may sound counter to the definition, but it's actually not really. It's just in the way that we say it. And I know we say it in that way just because that's the way that Bronsted-Lowry originally gave the definition until we understood what was going on. And now that we understand what's going on, really what Bronsted-Lowry is saying is that the base is taking that hydrogen away, and it's taking that hydrogen away with this lone pair, which is really the definition of Lewis acid. So we are going to remove the hydrogen, and I asked you to draw the conjugate base and conjugate acid, so I would just go ahead and do that first. If I'm taking the hydrogen away from the acid, you're going to form your conjugate base. You're going to have the sulfur become negative and the OH minus become neutral because it's going to pick up the hydrogen. Really, we're just trading this hydrogen over to the base. So the mechanism arrow is always going to start from where we have the electrons. So I'm going to point it from any of those lone pairs. I'm going to put some notes here, and we're going to come back to this. Number one mistake that I saw is that the electrons come from the lone pair on the oxygen, not from the charge symbol, and not from hydrogen. And that's because hydrogen has no electrons on it. So you can't do that, right? The number two thing that I saw is people pointing the arrow into just random space. You have to point the arrow towards the element you want to form a bond with. So really what this is showing you is that this is what this really means. The translation is I'm forming a sigma bond between oxygen and the hydrogen. Okay, so it's the translation for that. Now, hydrogen can only have one sigma bond. So if I'm forming a bond between the OH and that hydrogen, that extra bond to the sulfur makes me go over the number of electrons that the hydrogen can have. It can't actually have two bonds. So I'm going to need to break this sigma bond. So to break it, this is where my electrons are that will eventually become that extra lone pair. So I'm going to take it from the bond. Now, another mistake that people make is moving from the hydrogen. But remember, you need electrons for the start of the arrow. And hydrogen has no lone pair on it, right? There's no lone pair on that hydrogen. So what you need to do is share electrons from the sigma bond to the sulfur. And that's why sulfur is negative, because it's gained electrons, whereas the OH lost electrons by picking up hydrogens. All right, so that's actually the answer to this problem. Now, for some of you, you got this 100% correct. Some of you got some little tiny things incorrect. For example, some people were missing the charge. Every time you miss a charge, it's -2 on any assignment from here on out, okay? And if you become outrageous, we take more points off. So every time you miss charges, at minimum, you're going to get -2. The second thing is some people had the arrow from the OH to the hydrogen and just left it. If that's the case, you're going to end up with 3 bonds on the hydrogen because you never got rid of the hydrogen from the sulfur. Another mistake that people were making were throwing the electrons into space, into the air. They weren't pointing at anything. So you need to be careful that you point directly at something. You want to also be careful that you're not pointing electrons from charges. Remember, you're moving lone pairs. The charge is just a way to tell you something is happening. They don't come from the charge itself. So Most of you did a fantastic job. Some of you are getting very better. So the rest of you who didn't do so well, you're getting there. And I'm very proud of you. So I want you to keep the work up, but definitely come see me if you need any help. All right.